and we'll continue. Alright, so starting at the top. If you plot the surface distribution of granite, which is located over in all the X's over here, and the sandy soil, which is in the Y's all the way over in this part of your map, you will construct a simple geographic or geologic map. Okay, this is helping to basically tell you what is actually on the surface and what's also found in the soil. This map only tells you the type and position of rock and soil at the surface. Okay, this is just for this map. Now we're going to take this piece of information, we're going to fuse it and make a map that's going to also include the stuff that's underneath the ground. But in order to do those two together, we need some information. So here's what we need to do. To find out what's taking place below the Earth's surface at any given point, we will need more data to construct a true geologic cross-section. Fortunately, several other wells have been drilled in the area at locations 1, 2, 3, and also at location 4. From the well data, we know the depth below the surface to the granite body at each location. Again, because all the people that drill wells and drill for oil, they keep track of this information and know exactly what it is that they're drilling through so that they can better equip themselves if they have to go drill in that location again. For the sake of simplicity, here's what we're going to do. We're going to assume that the surface elevation in all of these places, all the way across here, is at 1,000 feet. And again, this is the surface level. This is like you walking on the grass outside at Hamilton Middle School. You would find that the elevation above sea level is about 290 feet. So it's the elevation at the surface. It has nothing to do with what's underneath the ground. It's just at the surface. So here's what we need, and this is the key point of information that is being provided for you right now. At well number 1, the granite lies 10 feet below the surface. So again, I would suggest that you underline, highlight, circle that piece of information because that's going to come back because you're going to need that in a few moments. At well 2, it's 20 feet below. At well 3, it's 30 feet. And at well 4, as we said before, it's 40 feet below the surface before you actually finally hit granite. So if the elevation, let's say at well number 1 on the surface is 1,000 feet, we have to drill 10 feet down before we hit granite. What's the actual elevation of granite? Well, you have 1,000 feet as your surface. You have to drill 10 feet down. 1,000 minus 10 leaves you at 990 feet is what the elevation would be for granite. And again, keeping in mind, the surface level where you're standing on is 1,000 feet, but the granite is 10 feet below you, so that makes its elevation 990 feet. Okay, so given those pieces of information, we can now see the granite surface slopes to the east. And again, north being over here, east going this direction, south, and then west. Going to the right, going to the left, up, down doesn't matter in this case. You have to be very specific when you give your answers when you're talking about direction. So again, the slope is to the east for the actual granite that we're finding. The outcrop starts here and then eventually slopes itself down into the ground to well number 4, where we know that it's 40 feet below the Earth's surface. If you haven't done so already, please turn the page over to page 11, where you're now going to be looking at this diagram right here. Now you're going to need your ruler and that strip of paper, okay, along with whatever you're writing with. The instructions on how to do this are located just below the picture in the italicized writing, obviously a little bit smaller, but I'm going to walk you through each of these steps so that you can construct the actual geologic cross-section. And then underneath is exactly what it's going to look like in the end. So there's the answer, but I'm going to show you how it is to construct that from the information which we've already been given and collected. Okay? The first thing that you need to do, as it says down here, it says you're going to lie the strip of paper on the geologic map. So you're simply going to lay it down like this. What I want you guys to do is line up the edge right here with the edge of the diagram. What that's going to do is going to make it a little bit easier for us to kind of draw things out, and it'll keep things a little bit straight a little bit more straight, and that will make constructing your graph that we're going to do at the end a little bit easier. Once you've laid the piece of paper down, what you're now going to do is you're going to mark a few land elevations on the map. For example, the granite elevation at the surface and the elevation of the sandy soil surface. What I'm going to have you do is I'm going to actually have you mark 4. Okay, we're going to mark 4 of them. The first one is going to be right here. This is going to be letter, and you can pick it up if you need to, but letter C. So we'll first make a little mark, and we're going to label that letter C. Over here, we'll mark the 1,000 feet. We're going to label that A. We're going to make a mark right next to the 1,000 here. We're going to label that B. And then we're going to make one more mark right over here at another 1,000 feet, and we're going to label that D. Now, we've labeled them, but we also need to include one other piece of information. We need to include their elevations. Okay, located up here for C, you're going to see 960 feet. So go ahead and label that under C, 960 feet. At A, it's 1,000 feet. At B, it's 1,000 feet. And also at D, it's 1,000 feet. So currently, this is what your piece of paper is going to look like. At C, you're going to find that you've got 960 feet. At A, 1,000 feet. At B, 1,000 feet. And then at D, 1,000 feet. So you've got those key pieces of information. Now go ahead and set this back down. The next piece of information, as we line it up, is we want the wells. And the reason why we want the wells is because this is where the granite is located. And we're going to now not just graph what we found for surface, we're now going to graph where the granite is located. So at well number 1, we'll make a mark, we'll label it 1. The elevation, we talked about this earlier, we read about it, we underlined it on page 10, is that well 1 is located 10 feet below until you hit granite. They had to drill 10 feet before they hit granite. So the elevation of granite is 990 feet. At well 2, we had to drill 20 feet. So the elevation is 1,000 minus the 20, and we get to 980 feet for well 2. Well 3, make our mark. Well 3 is 30 feet below the Earth's surface, so that makes it 970 feet for well 3. And then well 4, you might not be able to see it, it's underneath your strip of paper. Well 4, located here. Well 4 was 40 feet below the Earth's surface. 40 subtracted from 1,000 leaves us at 960 feet. So now your strip of paper has C, A, 1, 2, B, 3, 4, D. Those key pieces of information. What we're going to do now is we're going to use this information to construct this map. The map in which we're going to construct is going to be constructed using diagram E. This is the piece of paper which you all have, and I asked for you to have readily available at the beginning of class. So we're going to do it on diagram E. The first thing that you're going to do is you're going to lay your strip right across the bottom of the paper, just like so. This is going to help you to basically line things up. Now, the next step is we need to construct a Y scale. The Y scale is going to basically be, you could refer to it as elevation if you wanted to. So, looking at the numbers that we have, 900 all the way up to 1,000, what I'm going to do is I'm going to start by making a broken axis. Started at 0, broken axis. The first one I'm going to start at is 960, and the reason why, 960 is the first one. But if you wanted to, you could map exactly what you find right here on the diagram, where they started at 950. So why don't we just match it so that it looks just like what they have. So we'll go 950, 960, 970, 980, 990, and then 1,000 feet. Okay? Once you have constructed your Y scale, there's no need to construct your X scale at this point, because your X scale is really just located down here. We're going to use this just to help separate. Let's start with C. You're at 960 feet. Let's go ahead and make a mark at 960 for letter C. Let's go to letter A. Let's go up to 1,000 feet. Let's make our mark. Letter B, let's go to 1,000 feet, make our mark. And let's go to letter D. Go to 1,000 feet and make our mark. What I'd like you to do right now is I want you to take your ruler and I want you to connect the dots. Okay? And by connecting the dots, what we're now doing is we're showing what the surface elevation is at location A, B, C, and D. And you'll notice that from west to east, the elevation increases from point C to A, but then remains flat from A to D. So again, why don't we go ahead and label this as being the ground surface. And if you want, you can include the word elevation. Next, let's go back and lay your strip of paper across the bottom. And now what we're going to graph is the actual height of the granite. First of all, we know that there's a granite outcrop at location A. So why don't we again just make a simple circle right at location A. There's already one there, but we're just going over it again. Then at location well number 1, 990 feet. So we'll make a mark at 990. Well 2 is at 980. Well 3, 970. And well 4, 960. And now let's connect the dots here. What we're now doing is we're showing what the actual outcrop elevation has become now that it's underneath the actual surface. And how do we know it's underneath? Well, very simple. There is the geologic surface data mixed in with the geologic subsurface data. So if we wanted to, we can label this as being top of the granite. We know that there's granite located over in this area which is higher than the surface. How do we know that? Well, looking back at your map, on page 9, granite outcrop, telling us that the granite is above the Earth's surface. Whereas as we move to the east, past point A, past point B, and then in between, where over here it's labeled point D, you'll find that the granite's no longer on top of the Earth's surface, it's underneath. And that's exactly what we have just shown, is that the geologic cross-section shows the key features of the Earth's surface mixed with the actual items which are found underneath. And the only reason we know what's underneath the ground is because of what has been done with the drilling.